Hey everybody, this is part 2 of our transcription videos. So what I wanted to do is show you exactly how the RNA is made now that you kind of have an idea of what it's all for and stuff. So if we look at this, um, I'm making this whiteboard my entire DNA. My entire nucleus. Okay, so here's my DNA. Here's my nucleotides that are just kind of floating around in the nucleus. And what happens is, remember the DNA is a double helix and it has two strands, right? And A goes with T and C goes with G. So what happens to make RNA is that we get this guy here, and this is DNA polymerase. And what happens, it acts like a zipper to open up that DNA. So it comes in here and it splits it open like this. So this is going to give the opportunity for mRNA to be made. So remember, in mRNA, we're going from A to U and from C to G. So when we look here, my first one here is a G. So I'm going to bring this C in here, right? Because C and G go together. Now I have this T. T is still going to match up with A because RNA still has A, adenine. So I'm going to put this here. And now I have a G. And remember in RNA, G goes with C. So I'm going to have my C here. So these guys are just floating around in the nucleus, and now they know that they got to match up. Okay, now I have an A here, and I know that A has to pair with U because there's no T in mRNA. So I find my U's floating around and everything, and oops, tape didn't stick. Here we go with U. So these are building up, and I'm going to show you what the rest of it I need to put will look like. So I also have this G in here, but I made a little spot. Okay, so you can see how I built upon this. So I started over here. As it separates, we start building. So we had C, G, A, T, or let's start up top. G, C, A, U, because U is in mRNA, not in DNA. And C, G, A, U again, because there's no thymine in mRNA. T, A, G, C, A, again U, T, A, G, C, T, A, and C, G. So this is how it's made. And then what will happen afterwards is the mRNA will then move out of the DNA of the middle, and this will then close again to have a double helix. Okay, I want you to look here because remember my DNA has deoxyribose sugar and it has a phosphate, right? So those are my backbones in DNA. It's deoxyribose and phosphate. And notice my backbone here in mRNA. mRNA has a ribose sugar and it has the same phosphate. So the things that are different in mRNA is that we have a ribose sugar and we have a uracil instead of the thymine. And we are only one strand here, where this DNA is two strands. So you can see how these nucleotides are just hanging out, and when they get their call, there they come, bang, right up here. So I'm going to move this one so you'll see that this will then, like these would move with it, go out, and then this would close, and then my mRNA is going to then go out of the nucleus so we can make a protein during translation, which we'll be getting to. I hope that makes sense to all of you, and I will talk to you later. Bye.